Hey everyone, it's Mr. Glover here. We're just about to start the next video lesson, and today's topic's on developing the quadratic formula. So far, when we've worked with quadratics, we've solved them by either factoring them, or we've solved them by using square roots and tricks like completing the square. And the topic today is all about coming up with a formula that can always find us the solutions without having to factor. So some quadratic equations can be solved by factoring, such as x squared plus 8x plus 15. This one would turn into x plus 3 times x plus 5. But some can't be factored nicely, like x squared plus 8x plus 2. So if you can't factor it nicely, we need a way to solve for x without having to go through some sort of crazy process of factoring with fractions or decimals. What we're going to do is we're going to complete the square, then we're going to solve using square roots. So we're going to solve one question first, but we're going to do it in a structured way. And the reason why we're doing this is because after we do this question, we're going to go and do the same process to the general quadratic equation. And what will happen is when we're all said and done, we'll have a formula. It's a process called deriving, and essentially we're making a formula using our own logical steps, all right? So it's gonna seem a little bit weird, but at the end of the day, we'll make our own formula. So 5x squared plus 6x minus 7 equals 0 is the starting point. We're gonna start by moving the 7 to the other side, and we're gonna end up with 5x squared plus 6x equals 7. Then we've got to divide both sides by a, which is 5 in this case. We'll be left with x squared plus 6 over 5x equals 7 over 5. And now we have to complete the square. We've got to take b, which is 6 over 5. We've got to divide it by 2 and square it. So 6 over 5, if we divide it by 2, it's going to become 3 over 5, or 6 over 10. 3 over 5 squared, which is going to be 9 over 25. So we have to add 9 over 25 to both sides. X squared plus 6 over 5x plus 9 over 25 equals 7 over 5 plus 9 over 25. I'm then going to take the right-hand side and I'm going to try to write it as 1. So left stays the same, x squared plus 6 over 5x plus 9 over 25. The right-hand side, we have to multiply the first fraction by 5 over 5, with 35 over 5 plus, or 25 plus 9 over 25. And now, x squared plus 6 over 5x plus 9 over 25 equals 44 over 25. We just joined these fractions together. Now we can take the left-hand side, we can write it as a perfect square. It's going to be x plus something squared. And the question is what is the something? The something is what we have inside our other bracket. So it's b over 2, or 3 over 5. So we can write the left-hand side as x plus 3 over 5, all squared equals 44 over 25. We can then take the square root of both sides. X plus 3 over 5 equals the square root of 44 over 25. We should try to simplify this as best we can. 44, we can pull a factor of 4 out. It's like 4 times 11. So it will become 2 root 11. And we can square root the entire 25, turn it just into a 5. And the left is still x plus 3 over 5. Lastly, we need to move 3 over 5 to the other side. X equals 2 root 11. Oops. 2 root 11 over 5, plus or minus, plus 3 over 5. And technically, this should probably go first. So x equals 3 plus or minus 2 root 11 over 5. So that's an example of a pretty complicated problem that involves completing the square and solving a quadratic equation with fractions. We're going to now do the exact same process with the general quadratic formula or quadratic equation. So we can go through these steps for any equation in standard form, and that form is ax squared plus bx plus c equals 0. So what if we performed all these operations without numerical values? This is going to seem kind of weird. If you get kind of lost partway through this part, then don't panic too much, because the deriving part is not something I expect you to repeat on a test or something like that. But you need to know how to use the formula, and I'm showing you where it comes from, because this is the approach that you're going to see if you go on and study more mathematics. So follow the same strategy. We're going to move c to the other side, and it will become ax squared plus bx equals negative c. Then we've got to divide both sides by a. If we divide both sides by a, we'll be left with x squared plus b over a x equals minus c over a. All right, now this is the kind of weird part. We have to complete the square. We have to take b over a, divide it by 2, and square it. So b over a divided by 2 is b over 2a. We've got to then square it, and it's going to become b squared over 4a. And that's what needs to be added to both sides. Or sorry, 4a squared, really important. b squared over 4a squared. So we'll add it to both sides. X squared plus b over a plus b squared over 4a squared. And then the right-hand side, I'm going to add b squared over 4a squared. So minus c over a plus b squared over 4a squared. So now I'm going to go ahead, I'm going to take the right-hand side of the equation, and I'm going to try to join those fractions together. The left side won't change for the next few lines. It's going to stay as x squared plus b over a x plus b squared over 4a squared. But we need a common denominator here. It's going to be 4a squared. So this fraction needs to be multiplied by 4a over 4a. And it will become minus 4ac over 4a squared plus b squared over 4a squared. And then one more line, x squared plus b over ax plus b squared over 4a squared equals b squared minus 4ac all over 4a squared. Okay, we can take the left-hand side now. We can write it as a perfect square trinomial. It's going to be x plus something all squared, and that something is what was in our original set of brackets. It's going to be b over 2a. So the left-hand side is going to be x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Now we can take the square root of both sides. The left side will become x plus b over 2a, and the right side is the square root of b squared minus 4ac all over 4a squared. Now I'm going to kind of tidy up the right-hand side. I'm going to deal with that square root first, but you don't have to do it in this order. X plus b over 2a equals the square root of b squared minus 4ac all over 2a. 2a is just 4a squared square root. Now we need to finally move b over 2a to the other side. We'll do that by subtraction. So x is going to equal negative b over 2a plus or minus root b squared minus 4ac all over 2a. And now we have created the quadratic formula. If we join the right-hand side together, it will become negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula in its full glory. So we made it. We started with the general equation. We did a whole lot of algebra by completing the square, and we've made this formula. So for any equation, ax squared plus bx plus c equals 0, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the formula that I use almost exclusively when I have to deal with quadratics and I haven't been asked to factor it. So in a different realm, like a physics or a chemistry type situation, you're probably not going to waste a bunch of time factoring, and you're probably not going to get equations that factor nicely. This becomes your go-to when solving quadratic equations, to the point where you can even get programs for your calculator. There's one called Quadratic, where you just have to input A, B, and C, and you can just find a solution. So let's put it to the test. Let's solve for x. Now, a is always attached to x squared. It's not the first term. So if x squared is your first term, use that as a. If x squared is hidden in the second or third spot, it's still a. Okay? So in this question, a is 4. B is minus 7, the sign matters, and C is minus 1. So if we want to use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's going to equal negative b, which is positive 7, plus or minus the square root of b squared, which is minus 7 squared, minus 4 times a, which is 4, times c, which is minus 1, all over 2a, which is 2 times 4. So we're going to have a bit of simplifying to do here. This is not just going to simply be able to be punched in your calculator. And part of that's because we've got plus minus, and that's 2 operations. I'm going to simplify the bottom and simplify the square root a little bit first. So this is going to be 7 plus or minus the square root. 7 squared is 49. And now minus times minus is plus 16 all over 8. Now we can finally join our square root, or join what's in our square root together. We can turn it into 65. So this equals 7 plus or minus root 65 over 8. And now you've got a choice. I often will turn this into a decimal, but you don't have to. You can punch it all into your calculator at once. What you have to do, though, is you have to do 2 separate operations. You have to do the addition and the subtraction. So in one situation, we're going to have 7 plus root 65 all over 8. That is going to get us, let's see, 7 plus the square root of 65. That's going to get us 1.88. In one instance, we have to do our subtraction, so 7 minus root 65 over 8. So if we do the subtraction, 7 minus root 65, and divide it by 8, we get negative 0.13. So we actually have 2 possible answers here. And that comes from the fact that it's a quadratic and there's going to be 2 solutions. It also comes from the fact that we're adding and subtracting. Now, if you're using this in chemistry or you're using this in physics, one of these options is going to have to be discarded. And you have to think of the context. Usually in physics, you're solving for time. There's no going back in time, so negatives are thrown out. In chemistry, you're often solving for mass. There's no negative mass, so the negative gets thrown out. But technically, there are 2 answers to each of these. Let's try another one. This one's a little uglier. It's got fractions, And unfortunately, it's not organized in the same way as before. So we're going to have to rearrange it a little bit. Change it to 2x squared plus x over 3 minus 5 over 2 equals 0. Now we can see A, B, and C clearly. A is going to be 2, B is going to be 1/3, and C is going to be negative 5 over 2. So let's build the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's put in our numbers now. So minus b becomes negative 1/3. Plus or minus b squared. So b squared is negative 1/3 whole squared, minus 4 times a, which is 2, times c, which is negative 5 over 2. All divided by 2 times a, which is 2. So let's clean this up a little bit. Let's sort out our radicand. So this equals negative 1/3 plus or minus the square root of 1 over 3, all squared is 1 over 9. And then minus times minus is plus 20 all over 4. So now we've got a choice here. We can join these together into a fraction, and then we can take the square root of the fraction. I think it will be simpler for us if we simply just take the square root here, and we don't have to deal with fractions. So I'm just going to make the decision of turning it into a decimal. So the square root of 1 over 9 plus 20 is 4.48. That will make my life way easier. So this is negative 1/3 plus or minus 4.48 all over 4. Less fractions makes your life much easier. So we've got to do the adding and the subtracting. Negative 1/3 plus 4.48 all over 4. That gives us 1.03. So x is 1.03 in this case. If we do the subtraction, negative 1/3 minus 4.48 over 4, x will equal negative 1/3 minus 4.48, 4. X will equal negative 1.2. So we've got a couple of different options here. Both of these are answers to the equation, and if you went and you put these values in for x into your equation, your original function, it will equal 0. So we've got a couple more questions to do. So this first one here, 2x squared plus x over 3 equals 5 over 2. We're going to move 5 over 2 to the other side. So it's 2x squared plus x over 3 minus 5 over 2. Wait a minute. That's the same question. I suppose we won't be doing this question. But we can do the last one. So 4x times x plus 1 equals 5. Before we go and just call A4 and C5, let's actually expand our brackets and put everything on one side. So 4x times x is going to get us 4x squared, and 4x times 1 is going to be plus 4x. This equals 5. And then moving the 5 to the other side, 4x squared plus 4x minus 5 equals 0. Now we can see A, B, and C clearly. A is 4, B is 4, and C is minus 5. So using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. We'll go plug our numbers in. Negative b is negative 4 plus or minus the square root of b squared, which is 4 squared minus 4 times a, which is 4, times c, which is minus 5. All right, and this is all over 2a, which is 2 times 4. So this simplifies to minus 4 plus or minus the square root of 16 plus 80. It's plus because it's minus times minus over 8. This equals minus 4 plus or minus the square root of 96 over 8. And now we go ahead and we do our two calculations. X is either going to equal negative 4 plus square root of 96 over 8, or x will equal minus 4 minus the square root of 96 over 8. And I should probably point out, when you're putting these in your calculator, do the entire numerator in one shot and then divide by the denominator. Otherwise, your calculator will think you're just dividing root 96 by 8, and it'll give you the wrong answer. So minus 4 plus the square root of 96 divided by 8 is 0.72. So x equals 0.72 in this case. If we subtract minus 4 minus the square root of 96 divided by 8, x would equal negative 1.72. So when you're using the quadratic formula, there's a few things that you really need to keep in mind. First of all, don't worry about the order that the equation's written in. Worry about what the term attached to x is, the term attached to x squared is, and the term with no x, because those are going to be a's, b's, and c's. Make sure that everything's on one side of the equation, because as we saw up here, if the 5 is on the right-hand side, you're going to get the sign wrong when you go to put it in the quadratic formula. And lastly, take your time with the formula, put it in your calculator carefully, and if you get to the end and something doesn't seem like it's right, go back and double check. I mean, if you have the time, take these numbers, plug them back into your formula, and if the left side equals the right side, then you got the right answers. Anyways, I think I will wrap it up here. So this is going to be the end of the notes. I hope you all have a great weekend, and I'll see you all next week. Take care.